Okay, so good afternoon once again and welcome to today's class. I believe you can hear me and you can see my screen as well. I want to continue from where we left off in the last class. Now, in the last class, I introduced the concept of kurtosis and we looked at a question. I don't know if it is one or two questions we looked at. Was it a question we looked at on kurtosis or one? Can somebody please confirm for me, please? I remember I dictated a question to you. Compute the kurtosis of the distribution 2612. I don't know if that was the only question we considered on the subject matter, or we looked at another one. Can I get a feedback, please?
One question.
Just one question. Okay, since that's the case, I want us to look at yet another one before we now looked at the kurtosis as presented in here. Then I can now highlight the difference to you. So again, get your pens and calculator ready as I dictate this question. Example number 2. We did example 1 last week. Find the kurtosis of the distribution below and state what type it is. All right, just like we had it in the last class. So we're writing more or less the same thing. Only that this time I'm changing the numbers, and I want us to be super fast this time. Okay? So are you ready to take down the numbers?
Please, the question again.
Find the kurtosis, kurtosis, of the distribution below and state what type of kurtosis it is. Let me know when I can call the numbers for you.
Yes, sir. Yes.
Okay, so we have 42, 20, 38, 78, 54, and 26. I go over that again. 42, 20, 38, 78, 54, and 26. So if you were in the last class or if you have watched the video of the last class, it should be a walk in the park for you. All right, so let's get to work right away. Okay, so um yeah, in
Please,
your
sir,
worksheet,
can you recap the question, please?
42.
Oh, find the question.
Find the kurtosis of the
Okay.
distribution below and state what type of kurtosis it is. Have you gotten that?
Yes, sir.
So you have the numbers, right?
Yeah.
So quickly. Your raw sheet of paper. I want to pause. I want to give you some time to do this. Okay, so let's assume I'm giving you 4 minutes. I just want to give you 4 minutes, not more than that because of what we have to do today. So let's see how far you can go. Get to work, everyone. 143. We have 2 more minutes. We have a and voila, that's it. Wherever it is you have gotten to, let's stop now and let's get it done together. So who will tell me what's the first thing to get done?
To find the mean,
Good job. So find the mean. So the mean of y. How do you get that?
take the average of it, 40 divided by 6.
How do you get the average?
42 plus 20 plus 38 plus 78 plus 54 plus 26 divided by 6.
So the sum of all the values divided by the number of values you have added up. So when you add up and you divide, what do you get?
308.
I didn't hear you.
308.
Divide by 6.
That would be 51.33.
Are you sure that's the answer? Maybe I want to add again though.
I got
10.
43.
You got what?
43.
I have 43 too. So my sister probably might want to add again. You made a mistake somewhere. Are you on the same page now, everyone?
That's 258 over 6.
Divide by 6. You have 43 too?
Yes, 258
All right,
divided by
so
6.
at this point now, what do we need to do?
X
Talk to
minus
me,
X.
guys.
Okay, Y minus Y bar.
Y
Then I
minus
use
Y
X.
bar, like we did in the last class. So let's go. 42 minus 43, -1. This is -23. Give it to me. Let's go.
Minus 5.
Okay.
35.
35, right?
Yes.
Uh-huh.
11. Minus 17.
So what am I doing next?
We'll square it.
What am I doing next? Check your books from last class.
You square it.
Find the
Square.
square.
Square of this preceding value. And please, I hope you have sorted out these squaring negative values by now. So this is 1. What does this give you?
529.
Mm-hmm.
25.
And what is this?
1225. 1225. 121.
121.
289.
289.
289. All right, so this is for the second moment. So what am I doing next?
Find the fourth moment.
Sorry?
Find the fourth moment.
Fourth moment, which is expressed thus. So give it to me. This is still 1. And this gives you what?
So it's supposed to be raised by 4. not 2.
Okay, yeah, thanks.
279841. 625. 150. 0625. 14641. 83521.
All right, so what do we do here? We need to add up and get the sum of the second moment and add up and get the sum of the fourth moment as well.
2190. The sum of the second. 1879254.
All right, so at this point, how then do we get our kurtosis? Our kurtosis is given by the formula n into the sum of your fourth moment divided by the sum of your second moment squared. This is a 2, by the way. All right, so when we have this, let's input all of these values. What does this give us? N is how many? 6. Open a bracket. Our fourth moment we got from here, 1879254, divided by second moment, 2190, but we need to square it. So when we get this done, what is our final answer? Give it to me, somebody. Hello?
My final answer is 2.3509.
2.35.
09.
Now, okay, so this is fine. Either way. So based on this now, this is the kurtosis here. So what kind or type of kurtosis is it? Platychotic, mesochotic, or the third one, which is what? Leptochotic. What's the standard? What's the benchmark? We had a plus or -3 that we've been discussing about on the last class.
Platy.
So again, I didn't hear you.
Since it's less than 3, that should be the platychotic.
Platychotic type it is. So that's that about that. Now, let's go back into the CIS manual. The foundation for this has been set. Now, in the CIS manual, I don't know if you have noticed, the formula is a bit adjusted, different from what we have been using. This is simply so due to one reason. What is that reason? The two questions we have considered takes whole number values, but we could be given percentages like we have here. If you notice that from this question, we have been working with percentages initially, all right? So because of these percentages, that is why we are having this adjusted form for the formula for kurtosis. But the questions I gave you last week and this time around, we have used whole numbers that are not percentages. That's why we use the formula we used last week and the question we just considered now. Now, because of these percentages, emphasis laid on that, we are going to be going by what we have, the formula we have here now. That is what we want to consider here. And what is that formula? When your individual elements have percentages, this is what we stick to. It's just a bit of an adjustment. All right. So we know our fourth moment already. We know our standard deviation. This time raised to the power of 4. You know what n means. And again, you're not going to be required to cram all of these formulas. You have them at the back of your worksheets or your notebooks, exam answer sheets, rather. So you can always, since you know what you're looking for, you know how to apply them. So based on this, and bearing in mind that this is a continuation of what we have been doing before, we want to look at example number 15 here, which says, using the information on equity fund above, what we have done previously, compute and characterize the kurtosis of this distribution. Again, the standard deviation from prior, if you still remember, where is it? 13.65. Okay, I think we have done that from way back. All right, and like I do say, our classes are bricks upon bricks. You need to be up to speed with the previous classes before we can move on. So I want to type this formula we have here in the worksheet now. I want to write it out. So what do we have there? You have n. This is for kurtosis now. Is n. Let me write this slide. It can be a bit more space. N into n plus 1 all divided by n plus 1 n plus. So it's a minus. N minus 2, n minus 3. Then you multiply that by the sum of your fourth moment divided by your standard deviation raised to the power of 4. Then when you are done with this, you want to take away 3 into n minus 1 squared divided by n minus
Come in.
2,
Come inside.
n minus
Come in.
3. Okay, so let's confirm that. Yeah, so I guess that is exactly what we have here. So now that we have all of this, yes, I'm listening.
At what point are we going to consider this formula?
I said that earlier. I told you when the question you are given is based off of percentages, when the individual elements take percentages. Are we good now?
Okay, sir, thank
But
you.
if you have your individual elements being whole numbers, no percentages, then you stick to the initial method we used last week and just today, previously, before getting here. Is that fine, please?
Yes, sir. Yes, sir.
All right, so moving on. What are the things we need to put in place here? N. What is the value of our N? Or better still, let's start with let's start from here. Let's take it one by one to make the work easy. I want to take this bit first. So from the question, what is our N? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So let's input 10 in here and see what this gives us. This will be 10 into 11 divided by 9 times 8 times 7. Are we clear? This will be 1. Please just resolve this on a calculator and give me a final answer quickly. Who is helping out?
Please, can we have access to the question, please?
Access to what?
Can we just quickly write the question?
The question is in your manual. We're looking at example 16 in the CIS manual. Or is it 15 rather? Here. Are we clear, my brother?
Yes, sir.
All right, so again, we are using this formula. Why? Because the individual elements of the distribution are in percentages. Okay, so moving on, remember our standard deviation from prior is 13.65. So those are the items we are working with. We'll be using 13.65 here for our S. So has anybody gotten the final answer for this one?
0.22.
Can you give me to 4 decimal places?
0.2183.
For now, because we are not done with our work, all right? So that is settled concerning that. So now we want to move on to this second bit of the equation, this second bit here. Now, this second bit, I don't know if you still remember, I think we did x minus x bar to the power of 4. Did we do that? From the previous, if you have your notes from the previous class, did we do x to the power of 4? This bit. Can anybody remember, please? I'm not sure we did. Let me hear from you first, though. Hello?
We didn't do that. We didn't do it, sir.
Okay, so we did 2 and 3, right? But we didn't do 4.
Yes.
Okay, so we might need to do 4 now, quickly. That bit that, if you remember, oh God, unfortunately, I've deleted this. You know, the question we considered, what question is that again? Let me check. Example 14. Good. Here, we had x3. We did x2. I told you why we were doing x2 for the calculation of variance and finally standard deviation. Now, on this same table, if you still remember, we need to do x bar to the power of 4. Now, in getting this done, do not forget the manipulations we did. Okay? Please do not forget it. Where you still need to factor in your percentage of 100 and move your point by 2 zeros. All right, so that's what you want to do at this point. Wherever it is you did this in your notes, please refer to it now and then give me the answers for this portion of it now. I'm waiting. Let's work it together quickly. I hope you are not lost though, because it's really important that we all get carried along.
I think I am. I want to be clear. Like this example now, we've solved it before. Example 14. So are you
Yes,
saying that the new formula you gave us, is it for curtices that have percentages as their data? So we want to use this question to solve for curtices that have
exactly.
percentage. Okay.
Exactly.
Okay. Thank you.
So we go. You get your 3.16. Okay. Who can remind me? Let's start from here. Who can remind me of how this 0.0032% was gotten from here? From 3.16%. Anybody? Quickly. Oh yeah, now you've been in the class for the past 2 sessions at the minimum. Somebody help us quickly. Time is fast spent.
3.16 raised to power 3.
Are you sure? Did you put your percentage sign?
6.16 divided by 100. So the answer we got, we did a cube root of it.
Cube, not cube root, cube.
A cube rather, a cube of it. Then we moved 2 zeros. Then we add this answer.
That is okay, so that is clear for everyone, right? We've done this like twice now. We did it for x to the power of 2 and x to the power of 3. So now we want to apply the same principle for x to the power of 4. All right, I don't want to go over this again. That's taking a whole lot of our time. So let's go. This same 3.16%, however you want to choose to interpret it, that makes you understand it well. Take it to the power of 4. Then you apply the percentage principle, 2 zeros. Let me know what your final answer will be for this one. Let's go. Hello. Can you still hear me or my network is bad now? Hello, guys.
Yeah, with you,
We
sir.
can, we can hear you, sir.
Okay, so has anybody done the first one? Just be giving it to me as you get it. Or maybe we should divide again. We have 10. So let's divide it into 3. Who is taking this? Let me tag this A, B, C, and somebody will take the last one as D for us. So quickly. Volunteers, A, B, C. Please help me to cover enough ground today, guys. Please help me. Who is taking A? Who is taking B? Who is taking C? Hello. Is it confusing?
We are on it, sir.
Before we go far, so that I'm sure that we are doing the right thing. Can you just tell me what you got for the first one? 3.16%? What did you get for the first one?
So for me, I got 0.00009971.
All
Zero
right, so we
point
can.
zero 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 nine
Okay, let's
nine
just stick for now.
seven
So that means
one.
you're on track. 4 zeros, right?
Exactly.
Then 9%. Beautiful. So go on. Be mindful of your negative signs. If there's any other one you have done, you can just tell me so that I impute it here quickly. Give me something, guys. Which other one have you done? Hello, my people. Which other one have you done, please?
I've done for 2001 and I got 0.00259%.
Approximately 0.0026.
0.30.
Check again. Or did you move the percentages
Yeah,
accordingly? It should be 2.
percentage. Then
It
the
should
next
be 2. 0.0026. Not
should
3
be
zeros.
2.
Yes.
Yeah, that's what I mean. 0.0026%. That's
Oh,
what I
good
mean.
one. Then the third one.
then the following 0.0000022%.
I want final answers, please. Is that your final answer?
Do you get that?
I did.
0.0000
Zero point
for
zero zero zero
everything.
zero. No. Maybe you are doing it this way first. 21.66%. What does it give you here?
Yeah. Yeah, that's what I said. 0.0000022%.
You ought to move now. Are you sure you have moved by 2 zeros? Have you
I
considered that?
have. Before I moved it, it had 7 zeros. Yes, before I moved it, it had 7 zeros.
Wait, let me bring up my calculator. Can you see my calculator? So we have 21.66% to the power of what now? 4. Madam, are you with me, please? Hello?
Sir?
Are you with me?
Hello, sir. Hello, sir.
Can you hear me?
Yes, I'm with you.
Can you see my calculator here?
Yes, I can.
Did you get the same thing?
Yes, I've seen it.
So have
No.
you seen where you made a mistake probably? Anyway, can you get this? Can you able to input this in your calculator and get this same value? Please, I need you to respond so that you can move quickly. Hello? You guys are not responding. Or should I just
Okay,
simply
so
go on?
my whole network is not stable. I don't know why others are not talking.
Okay.
So, yes, I've seen my mistake. So now 0.22%.
Okay, so make it 4 digits for me, please.
Okay.
0.2201%.
0.2201%.
Okay? That's for the first 3. Then the first one here, 8.66%. Anybody's giving us that quickly? This will take forever. Let me just write out what I have in my book here. Then you can go and confirm it afterwards. So we have 0.0056%. Then 0.0867%. Then 0.4035%. Then 0.120378%. Then 1, 2, 3, 4, 5. Permit me to just write it here. 0.123450 zeros and 45%. Then you have 0.01016%. Then you have 0.3686%. All right, so these are the values you should get across board all the way down. So when you are done with all of that, you should sum them up. And when you sum up, you should get 0.69767%. All right, because of time, I will not be able to confirm this now, but whatever it is, you can look this up during the course of your revision and get back to me on that if there are any issues. So now that we have this sorted out, we need to impute this value, its summation, remember, the summation which we have just gotten here, into this portion of our formula here. All right, so we have 0.69767. Let me go into our worksheet. Where was I? Okay, that is it here. So this value which we got earlier multiplied by 0.6967% divided by the fourth root of our standard deviation. Now, if you look at the question, we were told already what our standard deviation was from the previous sessions, 13.65%. Okay? So when you take 13.65% our standard deviation and take it to power 4, can somebody do that for me quickly on your calculator?
So I have 0.0347.
Great. So let me just impute that quickly. 0.0347%. So now that we have this, what do? We are not done. There's a portion here which we still need to work upon. Let me just try and simplify this bit now on this side. So this is 3 into 10 minus 1, 9 squared, divided by 8 times 7. Okay, so let's simplify this on our calculator quickly. What do we get? Okay, this is 81. 81 times 3, 243. 243 divided by 70. What am I saying? 756. So what do we get?
4.3.
4 point. Can I get 2 decimal places?
4.34.
4.34 comes here. Okay, remember your board mass or bead mass. You know what comes first, subtraction comes last. So you need to simplify this bit first and foremost. So can we have somebody do that for us quickly? 0.2183 multiplied by all of this divided by that. What do you get as a final answer? Or better yet, just cut out this percentage and percentage here. So you know you're not working with that. So this times this divided by that, what do you get?
I have 0.049. I don't know. Is that what others got?
0.049.
Correct. 0.049.
Are you sure? Hope you can see my calculator.
Yes.
So what did you do wrongly? You have 4.39. Are we good?
You didn't minus, Abby?
I did minus what?
Sir, we gave you final answer.
Okay, what was the final answer you called, please?
It was 0.049.
Okay. Sorry about that. So final answer 0.049 or simply 0.05. Are we good?
Yes.
All right, so that's that about that. Let's head back into the book. Please go over all of this again. Just practice. It will come right at you if you practice and go through the videos again. So that settles all of this. Interpretation, mesocortic. All right. Why is it mesocortic here? Who can tell me why it's mesocortic? Hmm?
Less than 0 or close to 0.
Close to 0 or give or take equal to 0. So that's why. Yeah. All right. So that is that about that. Z-scores, we've done this before. Data collection. Please, I want to skip all this theory part. I just want you to go read them up. What is data collection, presentation, types? Please just go and read this all up. If you have any questions on them afterwards, let me know. Let's spend time on the things that we are likely to be really tested upon. So these are things I feel you can handle on your own. So please just go read it up. But whatever the case, we'll take it off from there. So you have review questions. Please practice them on your own. You have the answers there as well. If you have issues, just snap and send to me. I'll address them as soon as I can. But please make sure you have watched all the videos first before you start attempting questions. So that leads us to the next chapter and concept we want to look at here, which is probability. Okay, so let me just establish the concept of probability before we move into the text proper. So I have a bag. In the bag, I have balls, red balls, blue balls, and green balls. The number of red balls I have, 4, blue balls, 3, and then green balls, 3 as well. Okay, so what is the total number of balls I have? Oh yeah, now
10.
10. Now, probability is defined. Probability of any event is defined by how many of those events are present in the in the in the whole divided by how many things, number of, or let me just say the whole or total of things there. All right. So what is the probability of picking a red ball? Probability of picking a red ball will be what? How many red balls are in the bag? Somebody tell me.
4,
Divided by what is the total number of balls in the bag? 10.
10.
10.
Always take it to the lowest term. It's very important. This will be 2 over 5. What is the probability of picking a blue ball?
3.
3 over 10.
3
That's the
over
lowest
10.
term. Good. Now, what's the probability of picking a green ball?
3
3.
3 over 10.
So the probability
3
of
over
green ball
10.
is the same thing as probability of blue ball, which is 3 over 10. Now, questions could come this way. I need you to pay particular attention. What is the probability of not picking a red ball? So when you hear questions like that of not picking a red ball, what you do is 1 minus probability of red ball. Please note these things. So if the probability of red ball is 4 over 10 or 2 over 5, not picking a red ball will be 1 the whole minus your 2 over 5. That will end up giving you 3 over 5. Am I on track? Yes. Are you
Yes.
with me, please?
Yes.
Good. What's the probability of not picking a green ball? Who is telling me? Probability of not picking a green ball is what?
1 minus 3 over
10. And that will give you what?
um
Just do your denominator minus your numerator. 10 minus
7
3,
over 2.
7 over 10.
7
So
over 10.
so this is the idea. When you say 1 minus 3 over 10, this your 1 is the same thing as 10 over 10. All right. So to avoid all this, you just say your denominator minus your numerator. I did the same thing here. 1 minus 2 over 5. This my 1 is 5 over 5. Okay. So that will help you to get to your final answer as quickly as possible. So now that we have all that sorted, that's the basics for probability. There's one more, okay, and or. Let me also express that. And I've wiped this off for. Anyway, you have the number of balls and you understand it. So I'm using the same example. Okay? So the question might come and tell you, what is the probability of picking a red ball? Remember, this is red. And, okay, let's start with or. What is the probability of a red ball or blue ball? Are you with me? So when you hear or in probability, it means you should add or. Please take note of all these concepts I'm explaining. So what's the probability of red? We said it was 4/10 earlier. Or means plus. Probability of blue, 3/10. When you add up, so long your denominators are the same, you can afford to add up your numerators. It should be 7/10. Is this clear, please?
Yes.
Any dissenting view? Speak now or forever remain silent.
What of and?
I just joined,
One
so
at a time, one at a time. So are we done with all? Everybody understands all. Now, if the question had been probability of red and blue, you do what? You simply multiply. Okay, so probability of red again, 4/10 times probability of blue, 3/10. Okay, so I could just go 4 here, 2 here rather, 2, 2 here is 5. 2 here is 1, 2 here is 5. So 1 times 3, 3. 5 times 5, 25. Take note of the difference between this and this. It's really important. Are we clear with that, everyone? Who does not understand? Okay, so now that that is clear, let's delve back in. Oh, boy, I was on the book before, sir. Yeah, so all of these things you have here are still trying to explain all I have said so far. Now, there's one more thing I want us to look at. A mutually exclusive event and independent event. Is that what is being discussed here? Okay, so let's quickly look at them before we go on. Mutually exclusive event and then independent event. So who wants to give this a shot? When we say that two events, A and B, are mutually exclusive, what does it mean? When we say that those two events are independent events, what do they mean? Anybody wants to give this a try? Let me make it easier for you. Start with independent events. When I say A and B are independent events, what do they mean? Or what does that mean?
Means the outcome of A is not dependent on the outcome of B. They are existing
In fact,
individually.
there's no better way of saying it. Okay? The outcome of A is not dependent on the outcome of B. That means A can occur at the same time as B. One does not hinder the other. But when we now say mutually exclusive, if A happens, B cannot occur. Or if B occurs, A cannot happen. All right? So that is that about that. Okay, so and one more thing here. Probability must always sum up to give you 1. All right, the sum of every probability, like if you are done, okay, we had probability of red earlier, 4/10. Probability of blue, 3/10. And probability of what color was that again? Green, 3/10. If you add them all up, this is 10. It must always give you 1. 10/10, that gives you 1. All right, so that is that about that. That's what all of these are about anyway. So I just want to move on to portions where we have conditional probability, conditional and unconditional. Okay, so all of this still builds on what you have spoken about thus far. So unconditional probability is a straightforward answer to this question. What's the probability of one event occurring? This is what we have looked at. 70%, Okay. If we believe that a stock is 70% likely to return 50% in the next year, then probability of A, 70% likely. That's that about that. To do what? To do this. What's the probability of the stock returning 15%? You have said it's 70% likely to do so. So this is 70 over 100, 0.7. Unconditional. That's what we have been looking at so far, like the red, green, and blue balls you looked at. Now, this is where it gets interesting. The conditional probability answers a question. What is the probability of one event occurring? Please take note of this. Given that another event has already taken place. Okay? What is the probability that how do I put it now? Nigeria is going to win the African Nations Cup that is presently going on, given that what? Cote d'Ivoire, which is the home country of our coach, has been eliminated from the competition. Do you understand? So there's a condition that is already established before we want to now look for the probability of another thing. So the probability of another thing we are looking for now is based on an already established condition. I need you to please pay particular attention on this. A conditional probability has a notation this. See how it is written. Probability of A given that B has occurred. See it here. All right. If you believe that a stock is 70% likely to return 15% in the next year, as long as GDP growth is at least 15%, this as long as GDP growth 3% is the condition that has been established. Then we have made our prediction conditional on a second event, which is the GDP growth. The conditional probability of A given that B has occurred is equal to the joint probability of A and B divided by the probability of B, assumed not to equal to 0. So for now, let's just leave that one for now. When we get to numerical numbers, it will become clearer. Any questions so far? Any questions so far based on what we have looked at thus far? Okay, so in the absence of none, let's move on to the meat of the matter now. Conditional probability. Look at the formula here. What is the probability of event A happening given that event B has already happened? If that is the case, what do we need to do? You need to find the probability of A and B. A and B is like, okay, we mentioned and earlier. So you need to find the probability of A and multiply it by the probability of B when we say and. Then you divide all that you've gotten by the probability of B. That is what this line here is explaining to us. All right. So what is the probability of getting? Okay, let me go by what we have here. If you believe that a stock is 70% likely to return 15% in the next year, as long as the GDP growth rate is 3%, then we have, okay, so what is the probability of this happening? So you take this 70% probability for A, multiply it by the condition here, then you divide by the condition as well. So that's what the idea is about. Sometimes we know the conditional probability and we want to know the joint probability. Now, here, what we are looking at is simply change of subject or formula. Let me use much more simpler terms to express that. Now, suppose everything we have here is X. And then suppose this is what? Y. And this is Z. Then this can be expressed to be X is equal to Y divided by Z. Is this clear, please? Or rather, who doesn't understand? Can I get a feedback, please? Can I continue? Hello, guys. Can I continue, please?
Yes, sir. Let's do
Let's
example.
continue.
Maybe you
Okay. So, at this point, how do we make Z the subject of the formula? You cross multiply. So, you have XZ is equal to Y. Then you now come here to divide by X. then you know that Z is Y over X. If I wanted to make what now? Y the subject of the formula at this point where I had XZ is equal to Y. Okay, Y is already the subject of the formula here by simply multiplying both sides. So you must know how to manipulate. Your subject of formula is really very important. Now, we have done quite a lot of theoretical explanations. Let's look at example number 1 here. My voice is coarse already. Can somebody please read for me? Example number
The
1.
probability that the Central Bank of Nigeria will increase interest rate next quarter is 0.4. If the CBN increase interest rate, private sector credit flow will contract. The probability that the private sector credit growth will contract is 70%. What is the probability that private sector credit will contract and the CBN will increase interest rates?
Okay, so the probability that the Central Bank of Nigeria will increase interest rate next quarter is 0.4. If the CBN increases interest rate, private sector credit flows will contract. The probability that private sector credit growth will contract is 70%. What is the probability that private sector credit will contract and the CBN will increase the interest rate? Now, hold on. Where is this? Did I miss out something? Okay, seen it. So, here we are. How do we go about this question? You need to identify which is which. Which is the already established condition and what exactly are we being asked to find? Now, what is the formula again? There's a reason I did this. Okay, this is where I messed it up. There's a reason why I did this, okay? Based on what your question says, you must be able to identify, am I looking for the probability of A when B is already established? Or I am looking for the probability of A and B. Are you still following? Or I am looking for the probability of B all by itself. So look at the question again. What exactly are we looking out for? Then we know how to move. The question says, what is the probability that private sector interest rate will contract? What word is this? Clue. Somebody help me. What word is this? And. So of these three components you have here, let me tag this A. Okay, I've tagged them already. X, Y, and Z. Which of them do you think that you are being asked to find? Which of them? Are you looking for X? Are you looking for Y? Or you are looking for Z? Based on all what you have done so far. Anybody?
Y and Z.
I can't hear you.
Y and Z.
Y and Z. No, it can't be. It has to be one of the three. It can't be both. Are you looking for X? Are you looking for Y? Or you are looking for Z? Which? Which of them has and embedded in it based on what you have said so far?
X.
X does not have and embedded in it. X says probability of A given that B has occurred. What does Y say? Y is the probability of A and B. That's why you multiply them together. Are you following? Then Z is what? Just the probability of B. So based on this, you know that this example number 1 is requiring us to look for the probability of A and B, which is Y. The reason I had to do this change of sort of formula is to help us manipulate this formula. All right. So based on that now, let me write that formula again. Probability of A given B is equal to the probability of A and B, that's multiplied together, divided by the probability of B. So if I'm asked to find this numerator here, what do? I simply cross multiply. Then 1 times probability of B, I know that the probability of A and B now is equal to probability of A given B multiplied by the probability of B.
Yeah.
Is this clear, everyone? Who doesn't understand? Because I'm going to be putting numbers in now. I hope this is clear. Please speak. Speak if it's not clear. Who doesn't understand? Nobody. All right. So now that we have it established, we have manipulated the formula because we know what the question requires of us. What is the probability that private sector credit will contract and the CBN will increase the interest rate? And probably we have two variables we are looking at here. What are the two components we're looking at? The CBN increasing interest rates, the probability of the CBN increasing interest rate, and what? The private sector credit contracting. So these are the two items we have here. Okay? So which one is dependent on the other? So look at the question. We go. Based on what we have here, we know that our B is the interest rate. The probability that the CBN of Nigeria will increase interest rate next quarter is 0.4. If the CBN increases this, the private sector credit flow will contract. If this is done, this will contract. Now, the probability that the private sector credit growth will contract is 70%. Is it making sense to you, please? Can I get a feedback from you guys, please?
It's making sense.
I hope that's a consensus. All right. So the probability that the CBN will increase interest rate is 0.4. Now, if that is done, that's the condition. So you know that B is what? Your 0.4. B is simply the interest rate you are looking at. Because that is what needs to be done for something else to happen. So what is that something else that needs to happen? Our A. And what is our A? Private sector credit growth. So that is how it works. So now that we have this established, let's just impute the values. All right. So we go. What is the probability of A, B? The probability of AB, we have said, is the probability of A when B is established multiplied by the probability of B. Now look at the question. When B is established, when the CBN increases interest rate, what happens to A? Private sector credit growth contracts by what? 70%. So it means your 70% is coming in here. Then I am multiplying that by the probability of B, which is your 40%. Does this make sense, please? Multiply it together, you have 0.28. I want to hear from you. Does this make sense?
Yes, makes sense.
Good. So, any other person? Somebody else? Not very clear. All right, so what I'll do is, let's call it a day here. Please, again, go and watch the videos again. Maybe by the time you do it a second time, it will be better understood. Then we take it from there in the next class. We are already past the hour now, so let's just call it a wrap for today. Thank you for your time.
Welcome.
Thank you, sir.
Welcome. Madam Rachel is here already. All right. Thank you, guys. Have a good week ahead of you. Have I stopped recording? Madam Rachel, please help me stop the recording. I can't do this again. Can you hear me, please?
Lay, I'm with you. I'll do that. Good afternoon,
Please
sir.
stop the recording now. Good afternoon. You're welcome. Help me stop the recording. I made you the host before trying to stop the recording. Thank you. Bye-bye.